equal what? Ig alpha plus the moments of MAG around B. When you draw the free body, your rigid body, and you show that all forces are acting on the surface, it's called free body diagram. Free body diagram. Don't about my writing, I will send it to you, the lecture right in a good writing. So the free body diagram, it's your body, show all forces acting on this one, the external forces. Good? Once you draw the body again and you show the forces at G and Ig alpha, is called the kinetic diagram. So the free body diagram, it will be your first step in your problem. Why? Because the forces which are acting on the surface is given. Once you apply Newton's second law, you can get MAGX, MAGY. So you can do kinetic diagram. And you can finally calculate the moment around B. Let's say we have a beam, and this is moving in X direction with Ax like 5 feet per second square. Under acting of force like P is equal to 20 pounds. And the beam have a weight. The force B and the weight is equal, it's called external force, external force. So if you apply the Newton second law for the beam, it will be summation force in X direction, MEX. What forces do we have here in this equation? B or W? Yes? B, because we take the component in X direction only. If you apply in Y direction, what force we take? The Y. We take the component in Y direction. So it is important at the first step to rule the forces with Z angle. Which one is in X, which one is Y, or if it's an angle, you take a resolution X and Y. Before any other step. Good. If I told you I am interested to study the forces at a point A, or if I want to calculate the moments at a point A, or let's say, as an engineer, we want to judge if point A is a failure point or not. How to make that? Imagine, when you take a beam, point A inside the beam. So we want to know any information about A. You can give me information about the beam, about the surface of the beam. How to make that? Let's cut the beam twice. And here's the B, and each part have its weight. And this is point A from right side, and this is point A from left side. What else? What description about the forces and the moments at point A? 0. Some of the forces when you collect it towards it. But actually at the point A, there is what? Internal forces and the moments. So when you want to study the forces and the moments inside the body, you make a cross section at this point. Good? And ask yourself, in actual problem, point A can move in X direction?
What do you mean by that? Can A move the X?
Okay, let's ask you another. Just give me a minute. How many forces we have at A? Force in X, Y, moment around Z, or just X and the moment around Z, or Y, moment around Z, or we don't have any force in X and the Y and no have and no moments. What do you expect? Yes.
You'll have forces on X and Y and also X.
Why?
Because you have forces acting in the X and Y direction.
That's how to apply it. But the reason why the left, the right A, he wanted to move in X, but the left of A, he make a resistance. And the same for the left side. The left side, he wanted to move, but the right side, he make a resistance. Once you told yourself is a resistance, so we have a force. So we have a force here, like EX, and we have a force here, EY. In the other part, because it is a resistance, it is the same magnitude as a force, but in opposite direction. As a mathematics, when we collect them and make a summation to make a one body again, he will cancel each other. And also, we have moment around A. Why? Because point A, you wanted to rotate, the other part, you make a resistance, not rotate. Good? So, the internal force, it's like a resistance to the motion. Okay. Let's imagine we have a beam, and this is again point A, but point A is a bend. And we are interested to study the forces and the moments at a point A. Point A is what? Bend. So how many forces and how many moments here? At A. Yes.
When you say it's a bend, does that mean the beam is bending at A?
Yes.
Okay.
Ask yourself, we have a resistance, we have a force. We have a resistance to rotate, we have a moment. Here, we have a resistance to move. Spin. Yes. The beam can rotate. It can move in X direction, or Y direction, or Z direction. So we have forces in X, Y, Z. If you have a 3-dimension or X, Y, if you have a 2-dimension. But for rotation, can this body rotate around A? Yes or no? Because the spin can rotate. There is no resistance for rotation, so the moment will be 0. Assuming that there is no friction. Good? An ideal case. My explanation here is just, I wanted to compare between the external forces or internal forces. Internal forces, again, it's called reaction. And it's like a resistance to move or resistance to rotate. If you have a fixation point, you have a two reactions, you have a 2-dimension and 1 moment. If you have like a pen and the body is can rotate free, so we have only forces in x and y direction. Good. Let's solve this problem. We have a beam moving up with 0.5 feet per second square, and the beam have a diameter 2 feet. And as you see, the length is 20 feet. And the requirement determines the acceleration of center of gravity, A, and the angular acceleration of the pipe. Sorry. This is another problem. Required here, calculate moment around A. Sorry, I could be another problem, but it is the same given. And the weight is distributed like 500 pound per feet. Pound here is a unit of force or mass. I say the weight is 500 pounds per feet. Force, like the same as a force is equal mg. So the weight will be 4 times 5, which is the total length, times the weight rate, 500 pounds per feet. It will be 20 times 500. This is equal what? Pound. How to calculate the mass? The beam. The weight is equal to mg. So if you have a weight and the mass, direct calculation with will mg. G at 9.8 if you are a SI unit, or 32.2 if you are English unit. So the mass will be 20 times 500 divided by 32.2 will be 310.559 slug. So kilogram in SI unit, slug in what? English unit. Good? So that is a common mistake in the problems. When you solve a problem like that, you divide it by 9.8. Or in SI unit, you divide it by 32.2. It's a common mistake. Okay. Why I calculated M before I'm thinking about how to calculate the requirement. And once the required formation moment, ask about moment or force, you will apply using second law. And one critical element in your equation is the mass. So you must prepare your mass well. Good. Moment around the external moment or internal moment?
Say external.
Internal. Why? Point A inside the ring. And there is no application for any external moment. Good. So we need to what? To divide the beam at a point A. What forces we have here? Let's say the left one. We have a tension up. So we have here like T. Let's say T1. at an angle of 45. Why? You can see the cord of the rope is height 5 feet, and the distance between the new gravity